A concrete staircase climbs a mountainside in Colorado, worn smooth by hikers in ordinary running shoes. A swimming hole in the Texas Hill Country sits so clear you can read a coin on the bottom from 30 feet up. A turquoise pool in Yellowstone looks close enough to a warm bath that a boardwalk sign has to spell out. In plain language, exactly what the water will do to a human body if a visitor steps past the rail. A staircase up a mountain of crushed gravel outside a mining town in Oklahoma looks, from a distance, almost scenic. None of these places look like the kind of place that kills. That's the first fact worth getting straight before this list starts, because the word deadliest conjures cliffs, sharks, and lava, and most of what actually kills Americans outdoors resembles nothing like that. It resembles a staircase. It resembles a swimming hole. It resembles a parking lot at a trailhead with a paved path leading away from it. Here's the direct answer, since there's no reason to make you wait for it. The 20 places on this list are ranked by one measure, and only one: the confirmed number of deaths tied to a single, specific, place-bound hazard mechanism at that exact site, drawn from coroner reports, National Park Service and county incident logs, published geological and meteorological data, and, where the historical record allows it, the findings of the medical examiners who actually worked the cases. Not the surrounding county, not the general category of activity, hiking or diving or skiing treated as one broad bucket. The site itself, and the one specific thing about that site that keeps killing the people who go there. 18 of the 20 entries below are closed cases in the sense a medical examiner would use that term. A name, a date, a mechanism, a body recovered, or in a small number of cases never recovered at all. With no further entries expected because the hazard has since been fenced, sealed, gated, or otherwise removed from casual reach. 2 of the 20 are open cases because the hazard hasn't finished happening. It kills on something close to a yearly schedule, and for those 2, the number reflects a sustained, ongoing rate rather than a closed historical file. Every time that distinction changes where something sits on this list, it'll get flagged out loud, because ranking a slow, modern, recurring risk against a single closed disaster from decades ago isn't the same kind of measurement, and pretending otherwise would be the first error a real investigation would catch and correct. That's the surface answer, and it's accurate. Here's the deeper problem sitting underneath it, the one that actually explains why these 20 places made the list and not the ones you might expect. A death count by itself tells you almost nothing about mechanism, and mechanism's what this investigation is actually built to expose. A place with 3 recorded deaths from an invisible gas that kills in under a minute isn't a lesser hazard than a place with 30 recorded drownings spread across 4 decades of tourist traffic. It's a hazard operating on a completely different clock, through a completely different physical process, and treating both as interchangeable points on one danger scale would erase the exact distinction this investigation exists to draw out. Ranking 20 unlike hazards against one another by raw number would flatten that difference into meaninglessness on its own. A countdown still needs an order, though, and escalating stakes are the honest shape of what the historical record actually shows once you line these 20 cases up. The real content of this list isn't the number attached to each name. It's the 4 separate ways a landscape or a piece of built infrastructure can turn on the people standing inside it. Through geology, operating exactly the way geology is supposed to operate. Through weather, doing something statistically ordinary in precisely the wrong place, at precisely the wrong time. Through one specific human decision that looked reasonable in the exact moment it got made, and, a handful of times, through an event so improbable it shows up once in the entire historical record and then never repeats. Every place on this list gets investigated through whichever of those 4 lenses actually explains what killed people there. not through a fixed template repeated 20 times with the location swapped out underneath it. That's the deeper problem worth watching for as this countdown plays out. The mechanism changes every single time, and the calmest-looking places on this list are frequently the ones running the coldest, most mechanical process of all, indifferent to how the water or the rock or the air happens to look from where a visitor is standing. A note on scope, since a list more built on this kind of criterion has to draw a line somewhere and should say plainly where that line sits. This investigation deliberately excludes places whose dangers already common knowledge, sites like Death Valley's Furnace Creek Basin or the Grand Canyon's Inner Gorge, both of which post real, tragic annual death tolls, but neither of which needed an investigation to explain why heat or a 1,000-foot drop can kill a person. The title promises places you haven't heard of, and honoring that promise meant setting aside the famous hazards everyone already understands intuitively in favor of the ones that require an actual mechanism to be explained before the danger makes sense at all. It also excludes categories of death that, while real and often severe, aren't tied to a single specific location in the way this investigation requires, such as wildlife attacks or general road fatalities, since those risks travel with the animal or the highway, rather than living inside one particular square mile of American ground the way every hazard on this list does. What remains, after both of those exclusions, is a set of 20 places that share one final quality worth naming before the countdown begins. Each one requires a visitor to do something specific, to leave a path, to descend past a grate, to misjudge a climb, to stay somewhere a dam or a cargo hold makes dangerous, before the underlying hazard actually reaches them. That single shared requirement is exactly what the closing minutes of this investigation will return to. 20 places, counting down. Lowest confirmed toll first, highest last, and the highest last isn't close. Number 20 is a cave outside the small town of Alberta, Utah called Nutty Putty, and its confirmed death count's 1, which sounds like an odd place to open a Deadliest Places list until you understand exactly what happened there and why the state of Utah ultimately decided the correct response to a single fatality was permanent burial of the entire cave system, with the victim still inside it. Nutty Putty was a maze cave, several kilometers of narrow, twisting limestone passage first surveyed in the 1960s, popular for decades among recreational cavers precisely because its tightest sections delivered a genuine, low-stakes thrill. Squeeze through a gap barely wider than a pair of shoulders, pop out into a chamber on the far side, and feel like you'd actually accomplished something underground without any specialized equipment. On November 24, 2009, a 26-year-old medical student named John Jones led a group of family members into the cave and, hunting for a passage he remembered from an earlier visit, took what he believed was a known shortcut. He was wrong about which passage he'd entered. What he found instead was an unnamed, unmapped fissure that narrowed as it descended, tilting downward at close to 70 degrees until Jones was wedged headfirst and inverted in a gap that squeezed his chest tightly enough to make every single breath a deliberate act of muscular effort against the surrounding rock. Cave rescue teams reached him within hours of the call going out. They spent the next 27 of them trying every extraction method caving science had available at the time. A pulley and hauling system rigged through the narrow chamber directly above him, attempts to lubricate the rock around his hips, and repeated efforts to build leverage from angles that kept failing against the same basic geometry, because the passage narrowed in precisely the direction gravity was already pulling him. And no leverage point existed that didn't risk tearing him apart trying to reverse it. Jones went into cardiac arrest shortly before midnight on November 25th. The physiology behind that outcome is well documented in forensic medicine well outside caving specifically. Held upside down for hours, blood pools toward the head and upper body under gravity's constant pull, The diaphragm has to fight the weight of the abdomen with every inhale instead of simply relaxing to draw air in, and the heart is forced to work harder and harder against pressure it was never built to sustain for that length of time, until it eventually gives out entirely. That mechanism isn't exotic or unique to Jones's case. What was specific to Nutty Putty was the shape of the rock around him, an accident of ancient limestone deposition that built a funnel precisely narrow enough and precisely angled enough to convert one wrong turn into a trap no amount of trained rescue effort could reverse. County and state officials, after extensive consultation with Jones's family and the wider cave rescue community, ultimately decided to fill the entrance shaft with rubble and concrete rather than attempt a bore or an extraction that risked additional lives, and Nutty Putty has stayed permanently sealed ever since. It sits at number 20 specifically because it's a rare event in the exact technical sense that phrase deserves here. Not a hazard on any kind of recurring schedule, but a one-time geometric trap that only had to catch one person one single time to justify permanently closing an entire cave system to the public. Nutty Putty earned its name from the slick, clay-rich mud coating much of its main passage, a texture cavers said felt exactly like the children's toy, and for close to 50 years it functioned as an entry point into the sport for thousands of Utah teenagers on scout outings and college caving club trips, precisely because its known route was demanding without crossing into fully technical terrain. That reputation matters to a forensic reading of the case, because Jones wasn't a reckless first-timer. He'd caved there before and considered himself familiar with the system. What killed him wasn't inexperience in any general sense, but one specific wrong turn into a passage nobody had bothered to survey or name, because it looked, from its entrance, like dozens of other minor side passages that dead-ended safely after only a few feet. Limestone caves like Nutty Putty form through slow chemical dissolution along natural joints and fractures in the surrounding rock, a process that produces branching, unpredictable geometry, rather than the single engineered corridor a road tunnel would have. And that unpredictability is exactly why maze caves as a category depend on surveyed maps, updated continuously by whichever caving club actually uses them. Nutty Putty's own survey, built up gradually over decades of volunteer mapping, simply had not yet reached the fissure Jones entered that afternoon. Cave conservation groups across the country still cite the closure as an unusually difficult precedent, because sealing a cave isn't something the caving community does lightly. It removes recreational access for everyone in order to prevent a repeat of a single failure mode, and Nutty Putty's permanent closure remains one of the only times in American caving history that a lone fatality, without any broader pattern of repeat incidents at the same site, was judged sufficient reason to end public access entirely. The National Speleological Society's own accident reporting, compiled annually from rescue groups, law enforcement, and local caving clubs across the country, puts the typical American caving fatality count at somewhere in the single digits to low double digits most years, a small number relative to the tens of thousands of active recreational cavers nationally, and the leading causes recorded across that data are falls and simply becoming stranded or lost inside a system too complex to navigate back out of, rather than the specific entrapment mechanism that killed Jones. That context matters to where Nutty Putty sits on this list. It isn't evidence of caving as a broadly lethal activity, since the sport's overall fatality rate stays consistently low year over year, but a demonstration that even a low-frequency hazard can justify an extreme institutional response once the specific mechanism involved offers no viable path to prevention, short of eliminating access altogether. Number 19 sits inside Yellowstone National Park, at a thermal area called Norris Geyser Basin, and its confirmed toll at the exact pool involved is also one, a young man named Colin Scott, who died there on June 7, 2016. The basin surrounding him carries a documented history that makes it a meaningfully different case than Nutty Putty. Not a coincidence, but a pattern that park historians have tracked in detail for well over a century. Yellowstone sits on top of a supervolcano's shallow magma chamber, feeding roughly 10,000 separate hydrothermal features across the park, more than 500 of them active geysers, and researchers have cataloged at least 22 confirmed deaths tied to that thermal activity going back to 1890. More than any other single natural hazard, the park tracks in its own official records. The chemistry explains why that number has kept climbing across 130 years instead of staying flat after early safety measures went in. Yellowstone's hot springs aren't simply hot. Several, including the pool Scott fell into, run acidic enough to actively dissolve organic tissue rather than merely scald it, at temperatures the National Park Service has recorded above 93 degrees Celsius, close to 200 degrees Fahrenheit. Scott and his sister had left the marked boardwalk specifically to search for a pool warm enough to sit in, a practice park staff call hot potting and explicitly prohibit, precisely because the basin's safe pools and its lethal ones share no visible difference from the surface. Temperature and acidity both shift meter to meter across a thin, unstable mineral crust that can look identical from a distance of just a few feet. Scott knelt to test the water with his hand, slipped on wet, uneven ground, and fell in fully. His sister filmed part of the desperate recovery attempt on her phone before losing cell signal entirely and having to run to the nearest ranger station for help. And by the time a recovery team reached the pool the following day, a lightning storm had already delayed the operation once. What they eventually recovered was, in the coroner's own clinical language, largely dissolved. Norris's earlier cases follow the same basic script with different names attached. Fanny Weeks, a 40-year-old visitor from Washington, D.C., fell up to her waist into a hot spring near Old Faithful in 1905 and died of her burns a month later. Watt Cressy, a park employee, died in 1975 after jumping into a pool his colleagues later measured at 179 degrees while headed to a late-night gathering with co-workers who knew the area far better than most tourists ever would. The causal chain here has two separate, honest links, and keeping them separate rather than blurring them into a single dramatic story's the entire point of a forensic approach to this place. The geology did exactly what Norris's geology always does. Superheated mineral acid water sitting beneath a thin crust above a shallow magmatic heat source. The human decision, leaving a marked boardwalk to test or enter a pool by hand or by foot, is what converts a background hazard that millions of visitors walk past safely every single year into one specific fatality. 22 deaths across roughly 130 years, in a park hosting millions of visitors annually, is a low rate for a hazard this concentrated, and that low rate is itself evidence worth taking seriously. The boardwalks and the warning signs work. The deaths cluster almost entirely among the small number of people who choose to step past them. Yellowstone's roughly 10,000 hydrothermal features don't all pose equal risk, and part of what a forensic reading of the basin reveals is how much that risk varies by feature type. Geysers erupt on a cycle and are actually among the safer features to stand near at a respectful distance, because their column of water and steam moves upward and away from a viewer, rather than pooling underfoot. Mud pots are thick, acidic, bubbling clay that rarely reaches lethal temperatures at the surface, even when they look otherwise. The true hazard sits in the basin's open, still hot springs, pools that look glassy and inviting precisely because nothing's visibly moving on the surface, giving no outward sign of the near-boiling, acid-laced water sitting just beneath a thin, fragile mineral crust that can be barely an inch thick over hollow ground in places. Norris specifically hosts some of the most acidic water anywhere in the park, with pH readings in a handful of its features dropping below 2, roughly comparable to battery acid, a chemistry distinct from the more common alkaline hot springs found elsewhere in Yellowstone that, while still capable of causing severe burns, don't dissolve tissue at anywhere near the same rate. The National Park Service redesigned much of its boardwalk system through the 20th century specifically in response to the accumulating death toll, routing paths to keep visitors a fixed, tested distance from any feature capable of causing serious injury, and modern signage at Norris in particular is blunt in a way park literature elsewhere rarely is, warning explicitly that ground beyond the boardwalk can collapse without warning into scalding, acidic water. Every documented Norris area death across more than a century shares the same single variable: a visitor leaving that marked path. A forensic accounting of Yellowstone as a whole actually complicates the popular image of the park's danger, and that complication is worth stating directly rather than letting the more cinematic hazard stand in for the real one. Park Service mortality data covering the full span of Yellowstone's recorded history attributes roughly 125 deaths to drowning in the park's rivers, lakes, and waterfalls, more than 5 times the 22 attributed to thermal features, with vehicle collisions on the park's roughly 300 miles of road accounting for another 35. Yellowstone's rivers run near freezing even in summer, move with a current strength that isn't obvious from a calm-looking surface, and drop unexpectedly over slick, algae-covered rock, a combination that's killed more visitors than every geyser, hot spring, and mud pot in the park combined, despite receiving a small fraction of the press attention. That discrepancy between actual risk and perceived risk is precisely the kind of distinction a forensic reading of any dangerous place has to make explicit rather than assume. Norris earns its spot on this list because its specific mechanism, acid dissolution of human tissue within hours, is uniquely severe and uniquely well documented at this exact location. It doesn't mean Norris is the most dangerous place inside Yellowstone's own boundaries, and pretending otherwise would misrepresent exactly the kind of evidence this investigation is built to take seriously. Number 18 moves west into Death Valley to a fenced sinkhole called Devil's Hole, and the confirmed toll there's 2, both recorded on a single day, June 20th, 1965. Devil's Hole isn't a pond. It's the visible opening of a flooded fault cavern that divers and researchers have explored to a depth beyond 500 feet without ever finding a floor. A vertical crack in ancient carbonate rock connected to a regional aquifer so vast that seismic waves from an earthquake in Japan have been recorded sloshing the water inside it, thousands of miles from the epicenter. A physical demonstration of just how directly connected this small desert opening is to a groundwater system extending far beyond anything visible at the surface. On the day in question, 2 young men, 20-year-old Paul Giancontieri and his 19-year-old brother-in-law David Rose, climbed the fence around the site to go swimming, equipped with nothing but snorkels and fins, no scuba tanks, no guideline, and no real understanding of what lay beneath the surface they could see from above. Giancontieri dove down and didn't come back up. Rose went in after him and didn't resurface either. A professional diver named Jim Houts led a search effort with military volunteers that ran continuously for 36 hours before it was finally called off. And a second search attempt 3 days later turned up nothing but a mask, a snorkel, and a flashlight tied off on a ledge roughly 100 feet down, apparently left there by one of the men as a marker on the way in, that was never used on the way back out. Neither body has ever been recovered, across 60 years of intermittent searching since. The mechanism at Devil's Hole is straightforwardly geological rather than chemical, in direct contrast to Norris's acid chemistry, a shaft that drops far past the point where daylight can penetrate, water that stays a nearly constant 92 degrees Fahrenheit year-round, regardless of surface season, and a labyrinth of underwater side passages that a diver with no line and no light can enter within seconds and never manage to find their way back out of, disoriented in total blackness inside a cave with no fixed geometry a human memory can reliably hold onto under panic. The fence that failed to stop Giancontieri and Rose has since been reinforced, alarmed, and topped with additional barriers, not because the underlying geology changed at all, but because the failure here was entirely a matter of access rather than construction. Devil's Hole is also, separately from any of this, the only place on Earth the Devil's Hole pupfish exists in the wild, an inch-long fish confined permanently to a single limestone shelf near the surface. And the National Park Service's own dive team today operates under restrictions built as much around protecting that tiny, isolated population as around protecting future divers. A rare case where the endangered species concern and the human safety concern point toward exactly the same locked gate. The 1965 search for Giancontieri and Rose drew on resources far beyond what a typical missing persons case in the desert would receive, including active-duty military divers pulled in specifically because the cavern's depth and structure exceeded what most civilian recreational divers of that era were equipped or trained to handle safely. That mismatch between the site's difficulty and the casual way visitors could once access, it's precisely why the National Park Service's current protocol looks nothing like it did in 1965. Today, dives into Devil's Hole happen only a handful of times a year, conducted exclusively by a small, specially trained joint team from the Park Service and the U.S. Fish and Wildlife Service, primarily to survey and count the endangered pupfish population rather than for exploration. And every dive is planned around both the cavern's physical hazards and the ecological sensitivity of a habitat that's, at points, supported a total world population of fewer than 100 fish. The water's constant 92-degree temperature, warm enough to feel pleasant on first entry, is itself part of what makes the site treacherous for untrained divers, since it does nothing to signal depth or danger the way cold water often does by triggering an instinctive retreat toward the surface. Combined with total darkness beyond the first few meters and a network of passages that's never been fully charted even after decades of professional survey work, Devil's Hole remains a site where the geology itself, not any failure of modern oversight, still defines the outer limit of how far even trained science divers are willing to go. The gate and fence protecting Devil's Hole today exist for reasons beyond the 1965 drownings alone, since the site's remoteness has also made it a target for trespassing decades after that original tragedy. In April of 2016, 3 men drove an off-road vehicle around the perimeter fence after dark, shot out the locks on 2 separate gates, along with a security camera and several warning signs, and one of them climbed down and swam in the pool itself, leaving behind beer cans and a discarded pair of boxer shorts in water that supports the entire global population of an endangered species found nowhere else on the planet. Park biologists later found at least 1 pupfish dead, and all 3 men eventually pleaded guilty to federal charges, including destruction of government property and, for one of them, a direct violation of the Endangered Species Act that carried a prison sentence. The incident is a useful reminder that a site's official closure and its physical vulnerability aren't the same thing. Devil's Hole has been fenced for decades, and the fence alone has never been sufficient on its own to keep every visitor out. Whether the intent behind climbing its recreational curiosity or, as in this case, straightforward vandalism with no interest in the site's ecology or its history at all. Number 17 isn't a natural feature in the geological sense at all, but a staircase in Colorado Springs called the Manitou Incline, and it belongs on this list precisely because its danger comes from human physiology colliding with human overconfidence rather than from rock or water doing anything unusual. The incline began life as the maintenance track for a funicular railway built in 1907 to service a cable car climbing Pikes Peak's lower slopes, and after that railway shut down in 1990, hikers kept using the exposed railroad ties as an informal staircase for 2 decades until the city finally paved it, formalized it, and opened it as an official trail in 2013. What officials had formalized was roughly 3,000 steps, gaining close to 2,000 feet of elevation in under a mile, an average grade steep enough that some sections approach a nearly 1-to-1 rise, an ascent rate steeper than the internal stairwells of most skyscrapers, undertaken by hikers who frequently start the climb already at an altitude their bodies haven't acclimatized to, treating the whole thing as a fitness challenge rather than the mountaineering-adjacent physical event medical staff on scene actually consider it. Rescue crews respond to incidents on the incline on a regular basis, and confirmed cardiac fatalities have occurred there in recent years, including a 63-year-old man who died of a heart attack partway up in September of 2019, and a second 63-year-old man who collapsed and died on the trail in April of 2025. The recurring pattern rescue teams describe isn't inexperience with heights or navigation, since the route is a single, obvious staircase with no way to get lost on it. It's cardiovascular load, plain and specific. A steep, sustained, effectively anaerobic climb at altitude places a demand on the heart that resembles a clinical stress test far more than a hike, and unlike an actual stress test administered in a hospital, nobody climbing the incline is wearing a heart monitor or standing next to a defibrillator, and the paved trail gives no visual indication of how physiologically extreme the climb actually is until a hiker's own body starts sending warning signs partway up, often past the point where turning back is easy. The mechanism here's human error in close to its purest form on this entire list. Not a failure of equipment or a misread map, but a specific, repeatable misjudgment of what a body has actually signed up for. Made by people who assumed a paved staircase inside city limits couldn't possibly demand as much of a cardiovascular system as an actual mountain, when in measurable physiological terms it frequently asks more of a climber, in far less time, than most mountain trails ever would. Most hikers who summit the incline descend by way of the bar trail, a longer, gentler switchback route that adds several additional miles to the outing. And a portion of the trail's incident reports involve hikers who manage the ascent safely only to suffer falls, heat exhaustion, or exhaustion-driven missteps on the way back down, meaning the mountain's overall injury and fatality record can't be attributed to the climb alone. Emergency responders in Colorado Springs describe a specific, recurring profile among the cardiac cases: visitors, often arriving from lower elevations, who acclimatize for less than a day and attempt the incline as their first activity, without accounting for the fact that Colorado Springs itself sits above 6,000 feet before a hiker has climbed a single step, and the incline summit adds close to 2,000 more on top of that. There's no defibrillator stationed anywhere on the route itself, and cell coverage, while generally reliable along most of the corridor, still leaves rescue crews facing a genuine climb of their own to reach anyone who goes into cardiac arrest partway up, a response time that matters enormously for an event where survival odds fall sharply with every passing minute. City officials have resisted proposals to formally restrict access or require any kind of fitness screening, arguing that the trail's popularity and its role as a training ground for endurance athletes across the region outweigh a fatality rate that, while real and recurring, remains low relative to the roughly 250,000 visits the incline receives in a typical year. Number 16 sits beside a lake below Mammoth Mountain in California, and it carries 3 confirmed deaths from a hazard almost nobody visiting the site could see, smell, or otherwise detect before it killed them. Horseshoe Lake on Mammoth Mountain's southern flank sits directly above the Long Valley caldera, a vast volcanic system that last erupted catastrophically roughly 760,000 years ago but remains very much alive underground today, monitored continuously by the United States Geological Survey for exactly that reason. In 1989, a swarm of small earthquakes beneath the mountain opened new pathways for magmatic carbon dioxide to migrate upward through the soil, and by 1990, forest rangers noticed trees around Horseshoe Lake dying in expanding rings. their roots suffocated by soil gas that in some spots today still tests between 20 and 95% carbon dioxide, compared with roughly 1% or less in ordinary healthy forest soil anywhere else. The gas itself is odorless, colorless, and considerably heavier than air, meaning it pools invisibly in low-lying depressions, snow pits, and enclosed basements rather than dispersing the way most people instinctively assume any gas eventually will outdoors. On April 6, 2006, 3 members of the Mammoth Mountain Ski Patrol were reconfiguring warning fencing around a known fumarole, a vent actively releasing this gas, when the snow gave way beneath them and they fell into a covered pit that had accumulated a lethal concentration at its base, invisible from above right up until the ground itself failed. Breathing air at concentrations above roughly 7% carbon dioxide causes unconsciousness within minutes and death shortly after. And all 3 men died at the bottom of that pit, killed by a hazard tied directly to the same volcanic plumbing that built the mountain they'd spent their careers working on, in a location they already knew was dangerous, and were actively working to fence off when the fencing work itself became the exposure that killed them. The causal chain distinguishes this case cleanly from ordinary avalanche or fall risk on the same mountain. Nothing moved, nothing collapsed structurally, and no storm was involved anywhere in the sequence. The mountain simply exhaled, the way it periodically still does, into a pit that trapped the gas at ground level long enough to turn fatal before anyone inside it had a chance to react. The 2006 deaths at Horseshoe Lake weren't the first time scientists had recognized magmatic carbon dioxide as a hazard capable of killing without warning. A far larger, non-volcanic mountain event at Lake Nyos in Cameroon in 1986, where a sudden release of naturally accumulated carbon dioxide from a crater lake killed close to 1,700 people and their livestock in nearby villages overnight, had already established the basic physics internationally. This particular gas is invisible, has no smell, and settles into low ground in a way that can displace breathable air entirely before anyone nearby has any physiological cue that something is wrong. Mammoth Mountain's hazard operates at a dramatically smaller scale than Nyos, confined mostly to specific soil zones and enclosed depressions rather than an entire lake basin, but the underlying danger is chemically identical. Following the 2006 deaths, the United States Geological Survey and the U.S. Forest Service expanded continuous gas monitoring across the mountain's known tree kill zones, installed permanent warning signage around Horseshoe Lake explaining the hazard in plain language, and revised protocols for anyone required to work near a known fumarole, including a rule that nobody enters a snow pit or excavated area in those zones without a portable gas detector capable of flagging dangerous concentrations before a person's own body would. The tree kill areas themselves remain visible today as a stark, almost photographic warning, a ring of dead standing timber circling sections of otherwise healthy Sierra Nevada forest, a landscape-scale signature of a hazard that produces no smoke, no smell, and no sound. Number 15's a different kind of sinkhole entirely. A spring-fed pool outside Santa Rosa, New Mexico, known locally and now nationally as the Blue Hole. And it carries 3 confirmed diving deaths across exactly 2 incidents separated by 40 years. On the surface, the Blue Hole looks almost too pleasant to belong on a deadliest places list at all. A nearly circular pool about 80 feet across, fed continuously by an artesian spring pumping roughly 3,000 gallons of crystal-clear water a minute, widening to 130 feet across at the bottom, and for decades a popular certification site for beginner scuba divers, precisely because the visibility is exceptionally good compared with almost any other freshwater dive site in the American Southwest. What made it lethal was what sat below the visible bottom, invisible to a diver simply enjoying the recreational pool up top. At 81 feet, a metal grate today seals off the entrance to a cave system that's never been fully mapped. And in 1976, before that grate existed, two divers in a training class got separated from their group inside the unmapped passage beyond that depth and never found their way back out, disoriented in total blackness, the same way Devil's Hole's victims were. Inside a maze of side passages, a swimming pool-clear surface pool gives no visible indication even exists from above. That 1976 incident is precisely what led authorities to install the grate in the first place. 40 years later, in April of 2016, a team of experienced technical divers working with the ADM Exploration Foundation, surveying the cave system beyond the grate under a formal research permit and roughly 160 feet below the surface, lost 43-year-old Shane Thompson in an incident investigators described afterward as something going, in their own words, horribly wrong, despite his experience level and the team's careful preparation. Following Thompson's death, the same research team that had spent years surveying the system voluntarily covered and locked the grate to prevent further access beyond the recreational zone, closing this case the same way Nutty Putty was closed. Not by fixing the underlying hazard, since a flooded cave can't really be fixed, but by permanently removing casual access to it. The pattern across all three deaths, spanning 4 decades, is consistent rather than random. In every case, the fatal event happened past the exact point where the cave stopped being a swimming hole and started being an unmapped, lightless labyrinth. And in every case, training and experience reduced the risk substantially without ever eliminating the specific danger of a cave system that simply doesn't map or navigate the way open water does. Santa Rosa built much of its modern tourism economy around the Blue Hole, promoting itself for decades as a scuba diving destination in the middle of the New Mexico desert, hundreds of miles from any ocean, precisely because the site's exceptional clarity made it one of the best inland certification locations in the entire Southwest for divers earning their first open water credentials. That popularity is part of why the site's death toll, while real, has stayed comparatively low relative to how many total visitors and divers pass through it each year. The overwhelming majority of people who dive the Blue Hole never go anywhere near the grate at 81 feet, since the recreational zone above it offers more than enough depth and visual interest to satisfy a standard certification dive on its own. The 2016 fatality prompted a formal review by both city officials and the diving organizations that had been coordinating research access to the deeper system, and the resulting agreement restricted further cave exploration beyond the grate to permitted survey teams operating under strict safety protocols, effectively closing the door on the kind of informal, ambitious, exploratory diving that had periodically drawn technically skilled but underprepared divers toward the unmapped passage below. City officials have been explicit that the grate exists to protect divers from a hazard. The recreational pool itself does nothing to warn against visually, since the transition from a bright, clear swimming hole to a dark, narrow, mineral-walled cave system happens at a single depth marker most casual visitors never see. New Mexico's Blue Hole isn't the only body of water carrying that name, and the distinction matters for anyone researching the site afterward. The far larger and more famous Great Blue Hole off the coast of Belize is a marine sinkhole formed by a collapsed limestone cave during past ice ages, now flooded by the sea and popular with recreational scuba tourists diving its upper reaches rather than its unexplored depths. Santa Rosa's Blue Hole shares only the name and the basic sinkhole geology. It's freshwater, landlocked, spring-fed rather than tidal, and considerably smaller in surface area, though its cave system beyond the grate reaches depths that rival many marine sites. Divers travel considerably further to reach. The naming overlap has occasionally sent inexperienced travelers searching for dive conditions or safety information that actually describes the wrong hole entirely. A minor, but real example of how casually two geologically unrelated hazards can end up sharing a label that tells a searcher almost nothing about which specific risks actually apply to the water in front of them. Number 14 returns the investigation to weather, specifically to an avalanche path called Tunnel Creek, just outside the Stevens Pass ski resort boundary in Washington's Cascade Range, where 3 deaths on a single afternoon in 2012 turned into one of the most closely studied avalanche fatalities in American skiing history, precisely because the group involved included some of the most experienced backcountry skiers working in the sport at the time. On February 19, 2012, 16 expert skiers and snowboarders, several of them working professionals, set out together into Tunnel Creek's out-of-bounds terrain following a storm that had dumped roughly 32 inches of new snow onto the Cascades over the preceding 3 days. Fresh, heavy snow loaded onto an older, weaker layer beneath its close to a textbook avalanche setup. And the group knew that going in. Several members had discussed the risk openly before dropping into the run. What triggered the slide, investigators later concluded, was the skiers themselves, their combined weight and motion across the slope, disturbing a weak layer that finally let go as a slab avalanche roughly 200 feet across and 3 feet deep, sweeping 3 of them, Chris Rudolph, Jim Jack, and Johnny Brennan, a quarter-mile down a narrow, funnel-shaped gully that concentrated the moving snow instead of allowing it to spread out and slow down the way it might have across a more open bowl. The gully's specific shape is the geographic factor that separates Tunnel Creek from an ordinary open-slope avalanche. Terrain traps, meaning gullies, trees, or drop-offs sitting below an avalanche path, are what convert survivable burial depths into fatal ones, because the same volume of moving snow that had spread thin across open terrain instead piles up deep against a confined channel's walls, burying anyone caught inside it far more completely than the raw snowfall total alone would suggest. All 3 men died of trauma and suffocation, and the incident, later documented in exhaustive detail by journalist Megan Michelson's reporting for Outside Magazine, became a formative case study in how avalanche forecasters now teach terrain trap awareness specifically, precisely because the victims weren't reckless novices. They were people who understood avalanche risk professionally, discussed it openly among themselves before entering the terrain, and still misjudged how that one specific gully would behave once the slope beneath them actually failed. Part of what makes Tunnel Creek instructive rather than simply tragic is how the terrain sits relative to the resort boundary itself. Stevens Pass, like many western ski areas, allows skiers to exit through gates directly from patrolled, avalanche-controlled resort terrain into unpatrolled backcountry only a few dozen feet beyond the boundary rope. A zone the avalanche community calls side country precisely because it's accessible without the hike, because a kayaking form, snowmobile, or helicopter approach that usually forces backcountry skiers to plan more deliberately. That ease of access is exactly what avalanche researchers point to when explaining why Tunnel Creek drew 16 accomplished skiers on a single afternoon, rather than a smaller, more cautious group. The terrain felt close to the resort and psychologically close to resort-level safety, despite carrying none of the avalanche mitigation work Ski Patrol performs inside the boundary itself. The weak layer that failed on February 19, 2012, had formed weeks earlier during a stretch of clear, cold weather that allowed surface snow crystals to grow into large, poorly bonded facets through a process called temperature gradient metamorphism, and the subsequent 32 inches of new, heavy snow sat directly on top of that unstable layer, like a slab resting on ball bearings. Avalanche forecasters had rated the regional danger as considerable that day, a middle-tier rating that experienced backcountry travelers frequently ski through successfully by choosing lower-angle terrain, and the group's own discussion beforehand, later reconstructed through survivor interviews, shows they were aware of the rating and debated it openly rather than ignoring it. What the case demonstrates to every avalanche course that now teaches, it's that group size itself can quietly erode careful decision-making, since a plan 16 experienced people implicitly endorse by participating can feel more validated than the same plan would feel to any one of them alone. Avalanches kill an average of somewhere between 20 and 27 people across the entire United States in a typical winter, a national total compiled annually by regional avalanche centers working from confirmed, investigated incidents rather than estimates. Measured against that yearly national figure, Tunnel Creek's 3 deaths in a single afternoon represent an unusually concentrated share of an entire country's typical seasonal toll, claimed in the time it took one slope to fail once. The demographic pattern researchers have identified across decades of American avalanche fatalities skews heavily toward exactly the profile the Tunnel Creek victims fit. Experienced backcountry travelers in their 30s and 40s, disproportionately male, with meaningful prior training rather than inexperienced visitors wandering into terrain they didn't understand was dangerous. That pattern has held remarkably consistent across nearly half a century of data, and it points toward the same conclusion Tunnel Creek's own investigation reached. Avalanche fatalities in the United States are overwhelmingly a story about calculated risk among people who understood the danger reasonably well, not a story about ignorance, which is part of why avalanche education programs now spend as much time teaching group psychology and decision-making under social pressure as they spend teaching snowpack science itself. Number 13's a town, not a natural feature, and its story braids human error into weather more tightly than anywhere else on this list. Peacher, Oklahoma, sat atop one of the richest lead and zinc deposits in American mining history, worked from the early 1900s through the 1960s so intensively that by the time large-scale extraction finally stopped, the town was surrounded by chat piles, mountains of crushed waste rock left over from the milling process, some rising 200 feet into the sky and dwarfing the modest houses built in their shadow. That mining left considerably more than scenery behind. By the 1990s, federal researchers working the site under its Tar Creek Superfund designation found that 63% of children tested in Peacher showed elevated blood lead levels, a public health catastrophe caused entirely by decades of unregulated industrial extraction with essentially no meaningful environmental containment at the time, and residents were eventually offered federal buyouts to relocate. We'd sell me locate, slowly winding the town down through the 2000s. Then, on May 10, 2008, an EF4 tornado tore directly through what remained of Peacher, destroying more than 100 structures and killing 6 people in the town's core, before continuing on to injure roughly 150 more people across the wider surrounding area. The tornado itself was a natural weather event, statistically unremarkable for that stretch of Oklahoma's Tornado Alley corridor in early May. What made Peacher specifically lethal, beyond whatever a comparable regional storm would have inflicted on any nearby town, was the landscape a century of mining had already built around it. Those chat piles turned into deadly projectile hazards as the tornado's winds tore apart their loose, crushed material and drove it through the air alongside ordinary building debris, and a town already hollowed out by years of relocation offered fewer intact structures for shelter than it would have had a decade earlier, before the buyouts began. The causal chain here does have 2 separate authors working on 2 separate timelines. The tornado belongs entirely to weather, arriving on one specific afternoon. The vulnerability that turned an otherwise survivable regional storm event into a concentrated killing ground belongs to a century of unregulated mining decisions made by companies that were long gone before the funnel cloud ever touched down. Ground subsidence gave Peacher a second mining-related hazard, entirely separate from lead contamination and separate from the 2008 tornado. since decades of underground extraction left the town sitting atop a honeycomb of abandoned mine tunnels, close enough to the surface that unexpected sinkholes periodically opened beneath streets, yards, and in at least one documented case, a building foundation, long before the tornado ever touched down. That subsidence risk, combined with the lead contamination findings and the deteriorating condition of a town that mining companies had extracted enormous wealth from and then abandoned with minimal remediation, is what ultimately drove the federal buyout program that emptied Peach's population from more than 1,000 residents in the late 1990s down to a small fraction of that by the time of the tornado. Congress authorized the buyout specifically citing the combined mine subsidence and lead contamination hazards as making the town, in the government's own assessment, unsuitable for continued habitation regardless of any single disaster. The chat piles that turned lethal during the tornado remain standing today in reduced form, since remediation crews have spent years hauling the crushed rock away for reuse in road construction and other industrial applications. A slow, ongoing cleanup that hasn't fully erased the physical landscape a century of unregulated extraction left behind, even as the town itself has been almost entirely reclaimed by the buyout and left to the Quapaw Nation, whose historical tribal land the mining operation sat on in the first place, and who now oversee much of the ongoing environmental restoration. The Tar Creek Superfund designation dates back to 1983, making it one of the longest-running federal cleanup sites in the country. And engineers working the project have told regional reporters that full remediation of the groundwater contamination alone, separate from the surface chat piles, likely remains roughly 50 years away even now, a timeline that means the environmental consequences of Pitcher's mining era will keep being managed by people who weren't yet born when the last working mine shut down. That duration is itself part of the causal record worth including here, since it demonstrates how differently the two hazards braided into Pitcher's story actually resolve. The 2008 tornado was over in minutes. The mining contamination underneath the town it destroyed will still be actively monitored and actively costing taxpayers money to contain, for decades longer than any of the 6 people killed that afternoon would have lived to see it finished. Number 12 moves to a cliffside traverse on Kauai's Na Pali coast known as Crawler's Ledge, part of the longer Kalalau Trail, where at least 7 documented falling deaths separate this specific stretch from the rest of the 11-mile route surrounding it. The Kalalau Trail as a whole carries a broader safety record shaped by several distinct hazards, drowning at its beaches among them. Further down this same list, under a different name entirely. Crawler's Ledge is its own separate case, a narrow shelf of jagged, exposed basalt beginning just past the 7-mile marker, where the trail's usual red volcanic clay gives way abruptly to bare rock, and hikers cross a section with drops exceeding 300 feet on one side and essentially no protective barrier on the other. The geology explains why this particular stretch, rather than the trail generally, accounts for a disproportionate share of the fatalities recorded along the entire route. Basalt weathers unevenly over time, leaving a surface that alternates between solid, trustworthy footing and loose, crumbling rock with no visible warning marking the transition between the two. And rain, common on this exposed windward coast, turns the clay sections leading into the ledge slick enough to affect a hiker's balance well before they've even reached the exposed rock itself. A 28-year-old hiker named Zachary Rose fell to his death near the 7-mile marker in a widely documented 2014 incident, one of several falls recorded at almost exactly the same point on the ledge across different years, a clustering pattern that investigators studying trail safety have pointed to as evidence the danger sits in one specific, repeatable, geographic location, rather than being spread evenly across the whole traverse. As recently as May of 2026, a visiting hiker was found unconscious in the same section and later died. A reminder that despite decades of warning signage and an increasingly well-documented death toll, the ledge continues to draw hikers who underestimate how quickly a footing mistake on wet basalt converts into a fatal fall with nothing between them and the rocks below to arrest it. The basalt-forming Crawler's Ledge is part of the same volcanic sequence that built the entire Nepali coastline, a series of ancient lava flows that erupted, cooled, and were later carved into vertical sea cliffs by millions of years of Pacific wave action and stream erosion, cutting the deep, narrow valleys that make the coast impassable by road to this day. That geological origin explains the specific texture hikers encounter on the ledge. Basalt fractures along cooling joints as it hardens, producing surfaces that can look solid while actually resting on a hairline crack, ready to give way under a hiker's full weight. A hazard invisible to anyone without geological training and largely invisible even to many who have it. Rescue response along this stretch of coast constrained by geography in a way few American trails match. There's no vehicle access anywhere along the 11-mile route, meaning most rescues, including recovery of hikers who have died at Crawler's Ledge, depend on helicopter extraction, weather permitting, or a multi-hour evacuation on foot in cases where wind or cloud cover grounds air support entirely. Hawaii's Department of Land and Natural Resources introduced a revised permitting and camping plan for the trail in 2026, following the most recent fatality near the ledge, aimed at reducing overall visitor volume and improving how safety information reaches hikers before they ever reach the 7-mile marker. Though officials involved in the plan have been candid that no permit system changes the underlying geology of the ledge itself. What sets Crawler's Ledge apart from most of the entries higher on this list is how little separates its most experienced hikers from its most careless ones in terms of actual outcome. A person who has crossed the ledge safely 20 times is relying on the same narrow band of trustworthy basalt as someone crossing it for the first time, and neither one can reliably tell, by sight alone, which specific handhold or foothold has weathered into a hazard since the last time anyone tested it under load. That's a meaningfully different risk profile than most of the weather-driven or chemical hazards elsewhere on this list, where preparation, timing, or specialized training measurably change the odds. On wet basalt, above a 300-foot drop, geology sets terms that experience alone can't fully negotiate around. Number 11 takes the countdown back to Texas, to a spring-fed sinkhole outside Wimberley called Jacob's Well, which carries at least 8 confirmed diving deaths recorded between 1960 and 1985, with some historical accounts putting the true total closer to a dozen once earlier. Less rigorously documented incidents are included in the count. Jacob's Well looks, from the surface, almost identical to the Blue Hole nearly 700 miles away in New Mexico. Startlingly clear water, a popular swimming and cliff jumping spot for generations of Texans escaping the summer heat. What lies beneath the surface is the longest known cave in Hays County and the second longest fully submerged cave system in the entire state. Fjällen, dropping through a vertical shaft nearly 30 feet before angling into a labyrinth of chambers that reach an average depth around 120 feet, with one passage extending roughly 4,500 feet from the entrance, and a maximum depth past 137 feet. The specific geological danger is the sharpness of the cave's internal geometry, narrow angled chambers connected by tight restrictions that make it easy for a diver's body, and especially their tank and gear, to become physically wedged, a mechanical trap distinct in kind from the pure disorientation that killed divers at Devil's Hole and at the Blue Hole. Most of Jacob's Well's fatalities involved open water divers without cave-specific training or equipment, drawn in by how inviting and shallow the entrance looks compared with how quickly the passage narrows and darkens past that first chamber. Local authorities eventually installed grates and access restrictions of their own, similar to the response at the Blue Hole decades later, and Jacob's Well today functions as a heavily monitored swimming site above the Great Line. Autrine Assizes, with technical cave diving beyond it, restricted to permitted, experienced teams. A regulatory response built directly on top of a death toll that accumulated specifically because the entrance offered no visual warning whatsoever of the cave's true internal shape. Jacob's Well nearly stopped flowing entirely in the summer of 2000, when heavy pumping from the underlying Trinity Aquifer to support rapid residential and agricultural growth across Hays County drew the water table down far enough that the spring's flow dropped to a trickle for the first time in recorded history, a crisis that had nothing directly to do with the diving deaths decades earlier, but everything to do with why local officials eventually treated the site as worth protecting comprehensively rather than piecemeal. That near failure led to a dedicated groundwater conservation district and pumping restrictions specifically designed to keep the well flowing, and the broader protection effort folded diving safety into the same conversation as aquifer management, since both problems traced back to the same underlying cave system and the same fragile balance between public access and long-term preservation. Hays County today requires a permit for any diving beyond the recreational surface pool, and staff stationed at the site during peak summer months actively monitor swimmer behavior near the entrance shaft, a level of active supervision that didn't exist during the decades when most of the confirmed deaths occurred. The well's dual identity, as both a beloved regional swimming spot and one of the most technically demanding cave dives in the state, means safety officials there manage two almost entirely separate populations of visitors, the vast majority swimming safely on the surface and a much smaller, specially trained minority, accepting real risk below it, with the historical death toll drawn almost entirely from that second group. Number 10 belongs to Florida, to a remote sinkhole an hour north of Tampa called Eagle's Nest. 10 confirmed deaths since 1981 at a site cave divers themselves have nicknamed the Everest of their sport, not for any altitude involved, but for the reputation its depth and difficulty carry within the technical diving community specifically. Eagle's Nest opens as an unassuming sink in wilderness scrubland before descending through a long, rocky throat into a system of underwater passages that reach depths past 300 feet, technically classified as advanced cave diving territory, requiring specific certification, redundant gas supplies, and precisely calculated decompression planning long before a diver ever enters the water. What separates Eagle's Nest from a more forgiving cave system is less any single feature than the accumulation of hazards divers there have to manage all at once, failing to run a continuous guideline back to the entrance, misjudging gas reserves for a dive of that depth and duration, equipment failure at pressure, and a specific visual hazard where disturbed sediment on the cave's walls and ceiling can reduce visibility to zero within seconds, stranding a diver in total blackness with no line left to follow back toward the surface. On October 16, 2016, two skilled diving instructors, Patrick Peacock and Chris Rittenmeyer, died at Eagle's Nest despite their considerable experience, their bodies located the following morning floating at a depth of 260 feet, a death that shook the technical diving community specifically because both men were regarded as among the more capable divers who regularly attempted the site. What Eagle's Nest demonstrates more clearly than any other cave system on this entire list is that experience reduces risk without eliminating it. Once a dive crosses certain depth and complexity thresholds, every fatality recorded there involved a diver with meaningful training, and the site's continuing death toll reflects an unusually difficult physical environment rather than a pattern of unprepared novices wandering in over their heads, which is closer to the pattern behind several of the shallower entries ranked higher on this list. Cave diving organizations classify Eagle's Nest using the same tiered certification system applied across Florida's extensive network of spring-fed caves, and Eagle's Nest sits at the most demanding tier that system recognizes, requiring full cave certification at minimum, and for the depths where most fatalities have occurred. Additional training in mixed gas diving to manage the physiological effects of breathing standard air at extreme depth, where nitrogen narcosis can impair judgment in ways divers often fail to recognize in themselves while it's actively happening. The 2016 deaths of Peacock and Rittenmeyer prompted an investigation by Florida wildlife and law enforcement officials that found no equipment failure and no procedural violation serious enough to explain the incident on its own. A conclusion that unsettled the cave diving community precisely because it offered no simple lesson to correct going forward, unlike incidents elsewhere involving clearly identifiable training gaps or equipment problems. Divers who have surveyed and mapped Eagle's Nest over the decades describe a system where the margin between a well-executed dive and a fatal one can come down to seconds of decision-making. At depths where cold, narcosis, and the physical demands of the dive itself are all working simultaneously against clear judgment. And several of the system's most experienced local guides have publicly stated they now dive it less frequently than they once did, not because the site's changed, but because their own accumulated respect for its margin for error has grown with every additional year spent diving it. National statistics on American cave diving fatalities give Eagle's Nest's toll a broader context worth stating plainly. A peer-reviewed analysis covering 1985 through 2015 documented 161 cave diving deaths across the United States in that 30-year window, the overwhelming majority of them in Florida specifically, where the state's dense network of spring-fed caves makes it the epicenter of the sport nationally, the same way it makes it the epicenter of the risk. The same research found that annual fatalities declined significantly over those 3 decades, from roughly 8 deaths a year in the 1970s and 1980s down to fewer than 3 a year by the 2010s. A genuine safety improvement driven largely by standardized cave-specific certification, replacing the informal, self-taught approach earlier generations of divers had relied on. What troubled researchers studying the more recent data was a different trend moving in the opposite direction. The proportion of victims who were formally trained cave divers, rather than untrained open-water divers who'd wandered past a cavern's daylight zone, climbed from roughly 5% of fatalities in the 1970s and 1980s to nearly 30% by the early 2000s, evidence that training reduces risk without eliminating it, and that a meaningful share of modern cave diving deaths now involve exactly the kind of experienced, certified divers Eagle's Nest claimed in 2016. Number 9 moves away from water entirely to a wildfire on Storm King Mountain outside Glenwood Springs, Colorado, where 14 wildland firefighters died on July 6, 1994, in one of the deadliest single days in the modern history of American firefighting. A case investigators have since treated less as a pure natural disaster than as a chain of specific, documented human decisions, compounding an already dangerous fire environment. A lightning-caused fire had been burning slowly on the mountain for 2 days when a cold front moved through the region on the afternoon of the 6th, and the wind shift that front brought turned a manageable ground fire into what firefighters call a blow-up. A sudden, explosive acceleration in fire behavior driven by wind feeding oxygen into fuel faster than any crew on the ground can realistically contain. Crews working the slope, including hotshot teams and smoke jumpers, were caught below the fire on steep terrain as it raced uphill toward them at speeds later estimated to have exceeded a fast human sprint. And 14 firefighters died trying to outrun flames moving faster than the terrain allowed them to escape. The investigation that followed, conducted jointly by the Forest Service and outside fire behavior experts, identified several compounding human factors distinct from the weather itself. A failure to fully communicate red flag fire weather warnings down the chain of command to crews already working on the mountain. A decision to continue suppression efforts rather than withdraw once conditions started deteriorating, and gaps in escape route and safety zone planning that left crews with no viable path once the wind shift actually hit. Storm King Mountain reshaped wildland firefighting doctrine nationally. The incident is now taught at every federal fire training academy specifically as a case study in how weather alone rarely kills experienced firefighters, but weather combined with delayed communication and inadequate escape planning consistently does. 14 deaths in a single afternoon put Storm King well above the individual cave and sinkhole incidents earlier on this list, and it earns its place at number 9 specifically because its causal chain runs through both a genuine, statistically real weather event and a well-documented series of human decisions that turned a survivable blow-up into the deadliest wildland fire incident of its era. The doctrine that emerged directly from Storm King Mountain, known within the wildland firefighting profession as LHUS, an acronym for lookouts, communications, escape routes, and safety zones, is now taught as foundational material at every federal fire academy in the country, precisely because investigators found that each individual element of that framework had existed on paper before 1994. Teaching sure, but had not been consistently and rigorously applied on the ground at Storm King itself. A permanent memorial trail near Glenwood Springs today marks the specific locations where each of the 14 firefighters died, maintained jointly by the Bureau of Land Management and the families of those killed, and it remains a site fire crews from around the country visit as part of ongoing training, walking the same slope their predecessors climbed in 1994 to internalize how quickly a blow-up speed can outpace even a fit, trained firefighters' ability to reach a safety zone once conditions shift. Storm King is frequently discussed alongside an earlier, structurally similar disaster, the 1949 Man Gulch Fire in Montana, which killed 13 smoke jumpers under almost identical conditions, a sudden wind-driven blow-up on steep terrain that outran crews attempting to escape uphill, and the fact that fire services had absorbed the lessons of Man Gulch for decades without fully preventing a near-identical tragedy 45 years later is itself part of why Storm King's reforms were implemented with unusual institutional seriousness, treating the recurrence as evidence that verbal doctrine alone had never been sufficient on its own. Number 8's Waimea Bay, on Oahu's North Shore, a place whose name is inseparable from the history of big wave surfing and whose shore breaks killed with a grim consistency spanning more than 80 years of documented incidents. Unlike most of the sites ranked so far, Waimea's toll doesn't come from a single incident or even a handful of closely spaced ones. It accumulates, named case by named case, across generations of both professional surfers and ordinary tourists. Dickie Cross drowned there in 1943, caught by a rapidly building swell while attempting to paddle back to shore. His body never recovered afterward. Donnie Solomon died there on December 23, 1995. Driven under by a wave's full weight after failing to catch it and getting caught in what surfers call the impact zone, the area directly beneath a breaking wave's most violent force. Todd Chesser died nearby on February 13, 1997, pulled under by a set wave estimated at 25 feet after 2 hours of surfing that same session. Those are 3 named well-documented cases among professional watermen, and they sit alongside a far larger, harder to fully total number of tourist drownings in Waimea's inside shore break, a section lifeguards describe as one of the heaviest, most violently mutant close-out breaks anywhere in the world, a wave that can be 10 to 15 feet and break directly onto shallow sand with essentially no cushioning distance, catching swimmers who have no experience reading ocean swell and no idea that the bay's calm-looking days can turn seriously dangerous within an hour as a new swell rolls in from a storm thousands of miles offshore. The mechanism at Waimea is purely oceanographic, driven by North Pacific storm systems generating swell that arrives with enormous concentrated energy at a bay shaped almost perfectly to focus that energy onto one narrow stretch of sand. What places Waimea this high on the list isn't any single incident's severity in isolation. It's the sustained, recurring nature of the hazard itself, a wave mechanism that's proven capable of killing skilled professional surfers and untrained tourists alike, on a schedule tied to distant storm activity rather than to any single fixable failure that could ever be permanently corrected the way a fence or a grate can correct access to a cave. The bay's underwater bathymetry, a sharply rising seafloor shelf that shoals rapidly from deep water into shallow sand within a short horizontal distance, is what concentrates incoming Pacific swell energy into the violent shore break that's defined Waimea for surfers and killed casual swimmers alike, a shape distinct from more gradually sloping beaches elsewhere on Oahu, where the same swell arrives with far less concentrated force. That same bathymetry is precisely what makes Waimea historically significant to big wave surfing rather than merely dangerous, since it produces some of the largest reliably surfable waves in the world. And the bay hosts the Eddie Aikau Invitational, a surfing competition named for a legendary lifeguard and waterman who died attempting a rescue at sea in 1978. A contest so exclusive it only runs in years when swell heights exceed 20 feet, a threshold met only a handful of times across the event's entire history. Lifeguard staffing at Waimea increased substantially following the deaths of Solomon and Chesser in the 1990s, and modern beach safety signage explicitly warns visitors about the shore break's seasonal danger, since the bay's most violent winter swells arrive from November through March, while summer months bring conditions calm enough that the same beach functions as a popular, comparatively safe family swimming spot. A seasonal contrast that partly explains why visitors unfamiliar with Hawaii's swell patterns sometimes badly misjudge conditions on any given day. Professional big wave surfers today plan their sessions around buoy data and swell forecasting models sophisticated enough to predict wave height and timing days in advance, tools that have meaningfully reduced fatalities among the sport's most serious practitioners, even as the raw physical danger of the bay itself hasn't changed at all. That same forecasting information is publicly available to any tourist with a phone, yet it rarely reaches the people actually standing on the sand, deciding whether to wade in, which is less a technology gap than an attention gap. And it's precisely the kind of gap that keeps showing up across this entire investigation. The data required to see a hazard coming usually already exists somewhere before it kills anyone. Number 7's Camelback Mountain, sitting inside the city limits of Phoenix, Arizona. And it belongs on this list as an open case, a hazard that's, right now, actively killing people on a recurring seasonal basis, rather than representing a closed historical file the way most of the entries above it do. Camelback rises directly out of one of the hottest major metropolitan areas in the country, and its two primary trails draw enormous numbers of hikers, many of them tourists entirely unfamiliar with genuine desert heat, up exposed rock with minimal shade during a Phoenix summer, where morning temperatures routinely exceed 105 degrees Fahrenheit before 8 o'clock in the morning. Phoenix fire officials logged more than 100 mountain rescues across the city's entire preserve system in 2020-25 alone, with Camelback accounting for 44 of them, a share disproportionate to its relatively modest size compared with the city's other considerably larger preserves, and department data shows roughly 85% of hikers requiring medical treatment on these trails are suffering heat-related illness, rather than injuries from falls, meaning the dominant threat on this mountain is physiological, not the terrain underfoot. Confirmed fatalities occur most summers. Among the documented recent cases, a 31-year-old experienced hiker died on Camelback in July of 2023, despite starting early and carrying water, after temperatures had already climbed past 105 degrees by mid-morning. A case rescue official cited specifically because his own experience and preparation still weren't enough to overcome how quickly the mountain's exposed rock radiates stored heat back into the air surrounding a climbing hiker's body. The mechanism here's weather acting through both urban and geographic amplification at once, a desert basin trapping heat close to the ground, a rock surface offering essentially no shade cover across most of the ascent, and a trailhead sitting directly inside city limits, giving hikers a false sense of accessibility and safety that the mountain's actual thermal environment doesn't remotely support once they are several hundred feet up. Because this hazard's ongoing rather than historical, and because Phoenix's mountain rescue statistics have trended upward rather than flat across the past several years, Camelback sits at number 7 specifically as a reminder that this investigation isn't purely a museum of past tragedy. Some of these 20 places are still actively adding names to their record as this narration plays. Heat stroke, the underlying mechanism behind most Camelback fatalities, is a specific, measurable physiological failure rather than a vague description of feeling overheated. It begins once a person's core body temperature climbs past roughly 104 degrees Fahrenheit, and the body's own cooling mechanisms, primarily sweating, become unable to keep pace with heat generated by continued exertion and absorbed from the surrounding rock and air, a threshold that can be crossed within an hour or two of strenuous hiking under Phoenix's summer conditions, even in a hiker who feels reasonably fit at the trailhead. Phoenix Fire Department crews now perform helicopter short-haul rescues routinely from Camelback's steeper sections, lowering a rescuer directly onto exposed terrain where a ground team couldn't safely reach an incapacitated hiker in time, a capability the department built specifically in response to the mountain's rescue volume. City officials have also begun closing some Phoenix area trails outright during excessive heat warnings on the most dangerous afternoons, though Camelback itself has generally remained open even during closures elsewhere, both because of its popularity and because officials have found that closure signage alone doesn't reliably stop determined hikers, some of whom simply route around barriers. The mountain's two main routes carry meaningfully different risk profiles, with the shorter, steeper Echo Canyon Trail accounting for a larger share of rescues than the longer, more gradual Chawla Trail, a difference rescue crews attribute less to the terrain itself than to hikers, underestimating how much faster the steeper route forces their bodies to generate heat relative to the time it actually saves them. Number 6 is the Maze District of Canyonlands National Park in Utah, the second and final open case on this list, and arguably the most geographically extreme, in terms of what pure isolation alone contributes to its lethality once a hiker is already in trouble. The maze earns its name honestly, a tangle of sandstone canyons, fins, and dead-end passages so thoroughly disorienting that the National Park Service explicitly warns visitors that cell phone coverage is unreliable to non-existent across the entire district, and recommends carrying a satellite messaging device capable of triggering a rescue independently of any local signal at all. Recent years have brought a documented cluster of heat and dehydration deaths across Canyonlands more broadly, several specifically within or near the maze's outlying reaches, including a case involving a father and daughter from Wisconsin who became lost on a connected trail and ran out of water in temperatures exceeding 100 degrees Fahrenheit before managing to send a distress text, and separate documented incidents involving hikers who were found too late for rescue efforts to matter once they were finally located. What distinguishes the maze from an ordinary desert heat death, the kind that can technically happen anywhere across the American Southwest during summer, is the compounding effect isolation has on an otherwise survivable mistake. In most desert parks, a hiker who runs low on water and manages to call for help can reasonably expect a rescue response within a few hours, a window that keeps most heat emergencies elsewhere from ever becoming fatalities in the first place. In the maze, that same call might not connect to a tower at all, and even once it eventually does, ground access is slow enough, given the district's notoriously rough, high-clearance-only roads, that rescue teams have described response windows stretching into many hours rather than 1 or 2. The causal chain here layers weather, an entirely ordinary desert heat event by regional standards, directly onto geography, terrain that turns a routine rescue response time into something closer to an expedition in its own right. And that specific combination is what elevates a hazard that'd rank far lower almost anywhere else in the Southwest into the 6th spot on a national list. The maze formed through millions of years of water slowly carving vertical joints and fractures in cedar, mesa sandstone into an interlocking network of narrow canyons, fins, and dead-end alcoves that, from the air, does resemble a labyrinth built on purpose. And that same erosional complexity is what makes navigation without a detailed topographic map and real route-finding experience so difficult even for hikers who consider themselves competent in more forgiving canyon country elsewhere in Utah. The National Park Service requires a permit to enter the district's backcountry and strongly recommends, though doesn't legally require, a satellite communication device, a distinction park rangers describe as reflecting the practical limits of enforcement in a district too remote and too rarely staffed to check every vehicle before it heads down the district's rough approach roads. Those roads themselves function as an additional filter on visitor volume. Reaching the maze from the nearest paved highway typically takes several hours of high-clearance four-wheel drive travel across terrain that regularly strands underprepared vehicles, meaning the district receives a small fraction of the visitation that nearby, easier access sections of Canyonlands like Island in the Sky see each year. A lower traffic volume that, combined with extreme response times when something does go wrong, keeps the raw death count modest, even as the district's fatality rate relative to visitor numbers runs considerably higher than the park's more accessible zones. Number 5's Hanakapiai Beach, also on Kauai's Napali coast, a short hike from the same Kalalau trailhead, and unlike Crawler's Ledge several miles further along that same trail, a beach hazard rather than a cliff hazard, killing through drowning rather than through falling. The precise cumulative toll here carries a genuine documentation gap worth stating plainly, rather than smoothing over for the sake of a clean number. A sign posted at the trailhead by county officials tallies the beach's cumulative drowning count at more than 80, a figure the county itself maintains and periodically updates. A separate academic study covering the more conservative window between 1970 and 2010 documented roughly 30 confirmed drownings across that specific 40-year span. The two figures aren't necessarily contradictory. The sign's higher total likely includes earlier decades the narrower study never covered, plus incidents the formal research excluded for lack of confirming detail. But the honest answer's that no single, fully reconciled historical total exists for this beach. And that gap is itself informative about how this particular hazard actually operates. What both counts agree on completely is the mechanism. Hanakapiai has no protective reef, unlike most of Kauai's popular tourist beaches, meaning open ocean swell and current strike the shore with essentially no natural buffer to slow them down first, producing rip currents strong enough that the bodies of at least 15 victims have never been recovered at all, swept out past any reasonable search radius rescuers could realistically cover. There are no lifeguards, no warning flags, and no lifeguard station anywhere along this stretch of coast. A deliberate absence, given the beach's remoteness 2 miles down a trail with no vehicle access whatsoever, meaning every drowning here happens without any professional water safety presence nearby capable of intervening during the critical first minutes. The visual deception is almost identical to what makes Waimea Bay dangerous higher up this same list. A beach that looks perfectly calm and inviting can be actively running a rip current capable of overpowering a strong swimmer within seconds of entering water that, from the sand, gives no visible sign of what's actually happening 20 feet from shore. Ocean conditions along this stretch of coast shift dramatically by season in a pattern that catches visitors unfamiliar with Hawaii's swell cycles off guard almost every year. Winter storms tracking across the North Pacific from October through March generate the largest, most dangerous surf and the strongest rip currents, while summer months bring comparatively gentler water that can lull repeat visitors into treating the beach as safer than its own accumulated record actually supports. since a beach that behaved calmly in July can turn lethal within days, once winter swell season begins. The trail leading to Hanakapiai also passes a separate, distinct hazard worth naming, without folding it into the beach's own drowning count. Hanakapiai Falls, roughly 2 miles further inland along a connecting trail, has its own history of rockfall and flash flood deaths unrelated to the ocean current mechanism that kills at the beach itself. A reminder that this single trailhead funnels visitors toward 2 separate, mechanically unrelated hazards depending on which direction they choose to hike from the same parking area. County lifeguards and the state's Division of Boating and Ocean Recreation have run public awareness campaigns for years specifically targeting Hanakapiai by name, and warning signage at the trailhead is unusually explicit by American beach safety standards, listing the drowning count directly rather than using the vaguer hazard language most beaches rely on. A choice officials have defended as necessary, given how consistently visitors ignore more generic warnings elsewhere on the island. Number 4's Mount Washington in New Hampshire and its confirmed toll of 167 deaths since formal record-keeping began in 1849 makes it, by a wide margin, the deadliest single mountain in the eastern United States, a fact that tends to surprise people who associate mass mountaineering fatalities with the Himalayas or the Cascades rather than a 6,288-foot peak in New England that a paved road and a cog railway both reach the summit of today. The mechanism's purely meteorological, and it's extreme enough to have set a world record that stood for decades. On April 12, 1934, observers at the mountain's staffed summit weather station recorded a wind gust of 231 miles per hour, a reading that stood as the highest surface wind speed ever measured on Earth for decades afterward, and Mount Washington still holds the outright wind speed record for the entire Western Hemisphere to this day. The mountain's geography explains the extremity behind that number. It sits at the intersection of 3 major storm tracks, funneling weather systems arriving from the Atlantic coast, the Great Lakes, and the Gulf of Mexico into a single convergence zone. And the summit's own shape accelerates wind, the way a nozzle accelerates water under pressure, so conditions that'd be merely severe at the base of the mountain can kill within just a few thousand vertical feet of climbing. Hurricane-force winds, meaning sustained speeds above 74 miles per hour, occur on the summit more than 100 days a year, and recorded temperatures have plunged as low as 50 degrees below zero during the coldest winter systems. The 167 recorded deaths span falls, avalanches inside the mountain's steep ravines, hypothermia among hikers caught by weather that can shift from clear skies to total whiteout within an hour, heart attacks brought on by exertion at altitude in brutal cold, and, in one unusual case dating from the mountain's early tourism era, a horse-drawn coach accident on the old carriage road. More than 25 people are killed or seriously injured on the mountain in an average year even now, despite modern forecasting, well-marked trails, and a staffed visitor center actively warning hikers before they ever set out, which tells its own story about the specific nature of the danger here. Hikers routinely have accurate information before they ever leave the trailhead, and what kills them anyway is the sheer speed at which conditions on the summit can outrun their physical ability to react to information they already had in hand. The Mount Washington Observatory has maintained continuous, staffed weather monitoring at the summit since 1932, making it one of the longest-running mountaintop weather stations in the world, and the source of the meticulous historical death records that allow this kind of century-and-a-half accounting to exist at all. Earlier deaths on the mountain, including several from the 1800s tourism era when visitors in ordinary clothing routinely underestimated how quickly the summit's weather could turn against them, are documented specifically because observatory staff and local historians treated record-keeping as part of the institution's mission from its earliest years. The mountain's branding as home to the world's worst weather, a phrase the observatory itself uses in its own literature, reflects a defensible claim rather than marketing hyperbole, since the combination of extreme wind, rapid temperature swings, and dense fog that can drop visibility to a few feet within minutes occurs there with a frequency few other accessible mountains on Earth can match. Modern deaths on Mount Washington skew toward a different profile than the mountain's earliest fatalities. Fewer visitors die from simple unpreparedness for cold weather than in past centuries, since forecasts and gear have both improved enormously. But falls, cardiac events, and hikers caught by sudden, localized weather changes that outpace even an accurate forecast timing continue to account for the bulk of the modern toll. A pattern suggesting better information has reduced one category of risk on the mountain while leaving a different, harder-to-eliminate category largely unchanged. Number 3 moves from a mountain's weather to a dam's failure in Rapid City, South Dakota, where 238 people died on the night of June 9, 1972, in a flood that remains one of the deadliest single weather and infrastructure disasters in modern American history outside a hurricane or a major earthquake. The Black Hills received more than 10 inches of rain in just over 6 hours that evening, an amount of precipitation regional hydrologists later described as approaching the theoretical maximum the area's storm systems could physically deliver, overwhelming Rapid Creek and the smaller streams feeding into it almost simultaneously across the whole watershed. 7 miles upstream from the city center sat Canyon Lake Dam, a modest earth-fill structure only 20 feet high and 500 feet long, built originally to hold back a recreational reservoir rather than to withstand anything close to the volume of debris-laden water now surging down toward it. The flash flood carried enough uprooted trees, building debris, and loose sediment to clog the dam's spillway outright, and once the spillway stopped functioning as a working outlet, the reservoir behind it had nowhere left to go but directly over the top of the structure itself. The dam overtopped and failed catastrophically sometime after nightfall, releasing a sudden wall of water directly into a downtown area where residents had received minimal, if any, effective advance warning, given an era's flood alert systems that relied heavily on local radio broadcasts and word of mouth rather than the automated cell phone-based alerts available today. Total damages reached $160 million in 1972 currency, well over $1 billion adjusted to today's terms. And more than 3,000 people were injured, in addition to the 238 killed outright. The causal chain investigators established afterward runs through both weather and human engineering in roughly equal measure. The rainfall itself was a genuine, statistically extreme natural event on its own. The dam's failure is what converted a serious regional flood into a catastrophic one, because a structure designed for ordinary recreational water levels was never engineered to handle debris loading anywhere near what that single storm delivered in one night. And the disaster directly reshaped American dam safety regulation and urban flood warning systems across the decades that followed it. Warning systems that existed in 1972 did activate in some form that night, but investigators later found the alerts reached only a fraction of the population in time to matter, hampered by a combination of radio stations that had already signed off for the evening, phone lines that failed as flooding knocked out infrastructure across the city, and a general public unaccustomed to taking flash flood warnings as seriously as tornado warnings, which carried far more cultural weight in a region already primed for tornado awareness rather than flash flooding. In the disaster's aftermath, Rapid City made a decision uncommon for American cities rebuilding after a catastrophic flood. Rather than reconstructing homes and businesses along the original floodplain, the city converted the entire corridor along Rapid Creek into permanent parkland, a greenway that today includes bike paths, golf courses, and public green space specifically because no future development would ever again place residents directly in the path of a repeat failure, converting the flood's most dangerous ground into the one use that could absorb a future flood without killing anyone living on it. The National Weather Service cited the 1972 disaster directly in subsequent reforms to how flash flood warnings are issued and distributed nationally, including the development of more localized, faster triggering alert systems specifically designed to avoid a repeat of the communication failures that left so many Rapid City residents with no meaningful warning before the water reached their homes. Number 2 belongs to California, to a canyon northwest of Los Angeles, where the St. Francis Dam failed just before midnight on March 12, 1928, killing at least 432 people in what remains, by official death toll, the single deadliest American civil engineering failure of the entire 20th century. With researchers noting the true total may run higher still, since an unknown number of Mexican migrant farm workers camped directly in the flood's downstream path were never fully counted in that era's official tally. Unlike Rapid City, where a genuine natural weather extreme triggered the eventual failure, St. Francis had no storm to blame at all. The dam simply gave way on an ordinary night, under conditions its own chief engineer, William Mulholland, had personally inspected and approved as safe only hours before the collapse. The cause, established decisively in a 1995 geological reassessment by engineer J. David Rogers, sat literally underneath the structure from the moment it was first built. The dam's eastern abutment had been anchored into ground that turned out to be an ancient dormant landslide deposit, a mass of fractured mica-rich schist that nobody involved in the 1926 design process had the geological tools or the specialized training to identify as unstable, since the entire discipline of engineering geology as a formal field barely existed yet at the time. Once the reservoir behind the dam filled to full capacity, the sheer weight of held-back water reactivated that ancient landslide, and the eastern side of the structure gave way first, sending roughly 12.5 billion gallons of water down San Francisco Canyon in a wall reportedly more than 100 feet high at the point of initial collapse, flattening the town of Santa Paula and several smaller communities along a flood path stretching more than 50 miles all the way to the Pacific Ocean, and the flood didn't slow meaningfully until it finally reached the sea roughly 5.5 hours later. Mulholland, already a towering, largely unquestioned figure in Los Angeles civic engineering after building the aqueduct that had made the city's rapid growth possible in the first place, publicly accepted full personal responsibility and was formally cleared of criminal liability, with Rogers' later research concluding that no engineer working with the geological knowledge available in the 1920s could reasonably have detected the buried landslide sitting beneath the site. The lesson the disaster left behind reshaped an entire profession: engineering geology, evaluating not just what a dam is built from, but precisely what it's built on, became a mandatory discipline in American dam design, specifically because of what happened in this one canyon on one ordinary night, without a single drop of unusual rainfall anywhere in the causal chain. Some historical accounts place the toll closer to 450, rather than the more conservative official figure of 432, a discrepancy the earlier note about uncounted farm workers largely explains, and one worth stating plainly rather than picking whichever number sounds more dramatic. The disaster's regulatory consequences arrived almost immediately rather than decades later. On August 14, 1929, a little more than a year after the collapse, the California state legislature created what eventually became the Division of Safety of Dams, a state agency with authority to examine and approve every existing dam of jurisdictional size in California, to review plans and supervise construction of any new dam before a single yard of concrete was poured, and to require that dam construction proceed under the direct supervision of a licensed engineer. A requirement that sounds obvious today specifically because St. Francis demonstrated what could happen without it. California remains, as a direct legacy of One Canyon's failure in 1928, one of the more tightly regulated dam safety jurisdictions in the country, a regulatory apparatus built in direct, traceable response to a disaster that no storm, no flood, and no natural trigger of any kind had caused. Notification that the dam had failed reached downstream communities almost entirely through improvised human effort rather than any formal warning system, since none existed for a disaster nobody had anticipated. A California highway patrolman named Thornton Edwards, alerted by a phone call from the dam's own keeper moments before the structure gave way, spent the following hours riding a motorcycle from town to town along the flood's projected path, waking residents and urging them toward higher ground, ahead of a wall of water racing down the canyon, faster than most communities' own evacuation could keep pace with. The disaster ended William Mulholland's public career entirely. He retired from the Los Angeles Bureau of Water Works and Supply within the year, and his once unassailable reputation as the engineer who'd brought water to a growing desert city was permanently overshadowed by the collapse of a structure he'd personally certified as safe. Fragments of the original dam still stand in San Francisco Canyon today. Chunks of concrete the flood tore free and deposited downstream, some the size of small houses, left largely undisturbed as an informal, unmarked memorial to a disaster that, unlike Rapid City's flood or the Texas City explosion, has no official visitor center or dedicated museum. Its physical remains simply sitting in the canyon where the water put them. A quiet contrast to how thoroughly the disaster reshaped the engineering profession responsible for building it in the first place. Number 1. The deadliest place on this list by a wide margin is a stretch of industrial waterfront in Texas City, Texas, where 581 people died on the morning of April 16, 1947, in what remains the deadliest industrial accident in American history and one of the largest non-nuclear explosions ever recorded anywhere. The chain of decisions leading there's, in hindsight, almost entirely avoidable, which is part of what makes it a fundamentally different case than the natural or geological hazards ranked below it on this list. A French-flagged cargo ship, the Grand Camp, was docked in Texas City's harbor loading roughly 2,300 tons of ammonium nitrate fertilizer, a compound that's stable under most ordinary conditions, but becomes a powerful explosive under sustained heat and confinement. A fact well understood by chemists of the era but poorly reflected in how the material was actually being handled at the dock that particular morning. Around 8 o'clock, crew members noticed smoke rising from the cargo hold, and rather than flooding the hold with seawater, a decision was made to seal the hatches and pump in steam instead, out of concern that seawater would damage the valuable fertilizer cargo below deck, a choice that, instead of extinguishing the fire, effectively pressure-cooked the ammonium nitrate inside an increasingly hot, sealed compartment for close to an hour. At 9:12 that morning, the cargo detonated. The blast leveled the surrounding harbor district almost instantly, sent a fireball hundreds of feet into the sky, generated a shock wave that shattered windows as far away as Houston, 40 miles distant, and registered on a seismograph in Denver, Colorado, more than 700 miles from the source of the explosion. Among the 581 confirmed dead were 27 of the Texas City Volunteer Fire Department's 28 active firefighters, essentially the entire working department, who'd responded to the initial smoke report and were standing on or near the dock when the ship detonated beneath them. The department's sole survivor was a firefighter who happened to be off shift that particular morning. Adjacent chemical plants and additional docked ships caught fire from the initial blast, and a second major explosion followed roughly 16 hours later aboard another nitrate-carrying vessel nearby, compounding the death toll further as rescue and firefighting efforts already underway were caught in a second detonation nobody had adequately planned for. Given how little anyone fully understood at that point about how a single dockside fire could cascade into a multi-stage industrial catastrophe of this scale, Texas City reshaped American law directly and permanently, though not in the way survivors initially expected. Congress had passed the Federal Tort Claims Act only a year earlier, in 1946, finally allowing citizens to sue the federal government for negligence And since the ammonium nitrate had been manufactured, packaged, and shipped as part of a post-war government fertilizer program, roughly 273 lawsuits covering more than 8,000 claimants moved forward under that new law, in a test case that reached the Supreme Court in 1953. It remains to this day the single deadliest event on this entire list, deadlier than the flood in Rapid City, deadlier than the dam failure outside Los Angeles, deadlier than every cave, sinkhole, mountain, and beach ranked beneath it, all of them combined. The regulatory aftermath of Texas City extended well beyond American courts. The disaster contributed directly to the development of modern international standards for storing and transporting ammonium nitrate, since investigators traced much of what went wrong specifically to how casually the compound had been handled and stored in bulk quantities without adequate separation from ignition sources or emergency response protocols suited to its explosive potential under heat and confinement. Those lessons didn't prevent every future disaster involving the same chemical. The August 2020 explosion in Beirut, Lebanon, which killed more than 200 people after roughly 2,700 tons of improperly stored ammonium nitrate detonated at the city's port, followed a strikingly similar chain of institutional neglect, underscoring that the physical chemistry Texas City's investigators identified in 1947 had never actually changed. Only the willingness of subsequent institutions to respect it. Domestically, the disaster directly shaped how American fire departments handle hazardous material fires today, contributing to modern hazmat placarding requirements and to a firefighting doctrine that now explicitly trains crews to treat any fire involving an unknown or bulk chemical cargo as a potential detonation risk, requiring evacuation and specialized response. Rather than the aggressive, direct firefighting approach the Texas City Volunteer Fire Department had no way of knowing, on the morning of April 16, 1947, would cost 27 of them their lives. The Supreme Court's 1953 ruling in that test case, Dayliest versus United States, is itself part of the disaster's causal legacy, and an unwelcome one for the families who'd brought the suit. Rather than finding the government liable, the court ruled that the specific decisions behind how the ammonium nitrate had been manufactured, bagged, and labeled counted as discretionary policy choices immune from lawsuit under the new statute, establishing what legal scholars still call the discretionary function exception, a doctrine that continues to shield a wide range of federal decisions from negligence claims to this day. The practical result was that most Texas City claimants received nothing through the courts at all. And Congress ultimately stepped in years later with a separate act of direct compensation legislation, specifically because the judicial path the new tort claims law had seemed to promise turned out, once tested against a disaster of this scale, not to reach nearly as far as anyone expected when it was written in 1946. 20 places. And by the time this countdown reaches its top, a pattern sitting there whether the ranking calls direct attention to it or not. And it's worth naming plainly rather than leaving it implied. None of these places advertise their danger through appearance. A staircase, a swimming hole, a hot spring pool, a stretch of harbor dock, a dam holding back a recreational lake, a mountain reachable by a paved road, a beach with no visible current on the surface. In every single case investigated across this list, the mechanism that actually killed people was invisible from the position a victim occupied in the moments before it happened. Whether that invisibility was chemical, like carbon dioxide with no smell and no color, or geological, like an ancient landslide buried under a poured concrete dam, or simply a matter of scale. A rip current or a hurricane-force wind gust too large to perceive from inside it, the way a person can perceive an obvious cliff edge or a coiled rattlesnake. A second pattern sits directly behind the first, and it's the one this investigation kept running into place after place all the way down the ranking. Geology and weather build the hazard, but in the overwhelming majority of these 20 cases, one specific human decision is what converts a background risk that thousands of people walk past safely every single day into one particular fatality on one particular afternoon. A shortcut taken instead of a known route. A boardwalk left behind for a better photograph. A hatch sealed instead of flooded. A dam approved without the geological survey. That later disasters made standard practice across an entire industry, a fence installed years too late to matter. None of that makes these 20 places less dangerous in terms of how the surrounding rock or water or air actually behaves. The underlying hazard was always going to be there regardless of who happened to walk past it on any given day. But it does mean the honest final image of this list isn't 20 monsters lying in wait across the American landscape. It's 20 ordinary, often quietly beautiful places, each one running a specific physical process that most visitors will never once witness go wrong, and each one holding a documented record of the exact moment and the exact decision when it finally did. That brings the investigation back to the scope drawn out at the very start. The deliberate choice to leave out the famous hazards everyone already understands, and to keep only the places that needed an actual mechanism explained before their danger made sense. Every one of these 20 locations required something from the person who died there. A turn taken instead of a known route, a boardwalk left, a fence climbed, a hatch sealed instead of flooded, a swell misjudged, a mile of remote coast entered without a way to call for help. That requirement isn't a way of assigning blame to people who, in almost every documented case, had no real way of knowing what the specific rock or water or gas or wind in front of them was actually capable of. It's closer to the opposite. It's the clearest evidence available that these 20 places aren't haunted, cursed, or uniquely malevolent in any way the geology itself would recognize. They are ordinary physical systems, doing exactly what their chemistry, their topography, or their engineering was always going to do under the right conditions, and the only variable that ever changed was whether a specific person happened to be standing in the one place at the one moment when the system did it. A staircase in Colorado, a swimming hole in Texas, a pool in Yellowstone, a dock in Texas City. None of them look like the kind of place that kills, and that, in the end, is the actual finding this investigation kept confirming case after case, all the way to the top of the list. The deadliest places rarely announce themselves. The evidence has to be gone looking for. If one of these 20 mechanisms caught you off guard, the cave systems, the volcanic gas, the dam nobody checked the ground beneath, tell me which one deserves its own full investigation in the comments, because that's what decides the next case file. A like tells me the forensic approach actually landed better than another spooky places list would have. And subscribing keeps you here for the next place that looks nothing like what kills you. There's another overlooked one waiting after this.